The last topic in chapter 15 buffers is indicators. An indicator is something that changes colors between the acid form and the conjugate base form. So when we drew our titration curve, there's the equivalence point. Okay. Now, how do you find the equivalence point experimentally? There are two ways you can do it. You can use a pH meter. And a pH meter works by measuring the electrical conductivity. So if you have an acid and it is doing this, your ions are going to conduct electricity more than the non-ionic form. And so it basically measures the electrical conductivity. There are pluses and minuses to that because there might be trace amounts of other ions in your solution that might give you, not a perfect reading. But pH meters are pretty darn good, and you can do well by using distilled water, and so you can get pretty accurate readings. The other one is pH indicator. This is kind of more in the olden days. They're still used, but they're not as, I think, accurate as pH meters. So I'm going to define an indicator. An indicator is a very weak acid. I mean very, very weak acid. Weak to the point of it is like 10 to the negative 40th for the Ka. And you want your indicator, okay, it's an acid, so I'm going to write it as HIN, okay. You want the indicator to have two different forms color-wise. So like in the case of phenolphthalein, this form is colorless or clear, and this form is pink. So when it changes from the acidic form to the conjugate base form, the solution will change from colorless to pink. Okay? So your eye is sensitive enough that when the ratio of the conjugate base to the acidic form, is approximately 1 to 10, your eye will be able to begin to notice the color change. So in other words, at this point, when the ratio is 1 to 10, you would notice your solution turning a faint pink in the case of phenolphthalein. Okay. Now, there are many different types of indicators. So how do you choose the correct indicator for your titration? Well, it goes back to knowing where the equivalence point is. Okay, so the equivalence point, so let's say I'm trying to titrate this acid. Okay, and so when you're titrating the acid, you are going to add a base, okay, a strong base. Okay, in this case, I'm just writing sodium hydroxide. So the equivalence point is when the moles of acid and the moles of base are equal, right? So that means at that point, let's just say if I had 1 mole of this and 1 mole of this, all of this will react, all of this will react, and so I won't have any of this left anymore, and all I'll have is the A minus and water, okay? So the equivalence point is where the inflection occurs in your graph, right? So at that inflection point, that's the equivalence point, okay? So we want our indicator to change color right around there. Okay? So we want our indicator to change color at the equivalence point. Okay? So when does when do we begin to notice a color change? When the ratio is 1 to 10. So we would want an indicator who is going to change color at this pH, whatever that pH range is, okay? So we want the indicator to change color in this range right here. Okay, we want the indicator to change color. And when will we notice the indicator changing color? When this ratio here is 1 to 10. Okay? So this is like the beginning of the color change. And actually let's actually use pink here. So you would notice it's starting to turn pink there, and then it would completely turn pink at that point. So the beginning of the range would be this, and the end of the range would be when all of my indicator has turned into the, oops, I used the wrong one here. The end of the range is when all of this has turned into all of that. Okay? So basically, the range ends when the concentration of indicator over this is 1 to 1. When the ratio is 1 to 1, we've essentially reached our end of the range. And so the color change won't change anymore. It'll stay that strong of a pink the rest of the way. So this is the beginning of the range. So this is the beginning of the range. That's the end of the range. So log of 1 is 0. So the pH, this is the end of the range. And that's the pKa of the indicator. So in other words, I want the pH, I'm going to pick an indicator whose pKa is going to be equal to the pH range of where the equivalence point is. So that's how I pick my indicator, is I say to myself, okay, I've got all the pKa's or the Ka's of my acids and bases. There's a table in the book. So you go to that table in the book you take the log of those KAs of the indicator, and that will give you the pH at which the indicator will change color. Okay, so you take the pKa of the indicator, and that'll tell you the pH at which it will change color, and you want that to match up with your equivalence point.